During the first part of this lesson, we talked about what variables are. But let's show a couple of examples of how do we use variables in algebra and what paper do they play in the whole algebra concept. Yes, we're going to get deeper into these concepts later on, but let's understand an idea of variables in algebra. We use variables to solve different type of problems, to help us solve many different type of problems. Like one of the problems is the one shown on the screen right now. It says, the price of the purple book is $10, more than twice the price of the blue book. To write an equation, we need to first identify the characters of this problem. The first character is the price of the purple book, because it's given. It's something we want to know the price of that purple book. So let's just put a variable. Let's put P for purple, and this P represents the price of that book. If the purple book is $25, then P is going to be 25. If the purple book is $50, then P is going to be 50. The second character in this problem is the price of the blue book. It's also identified with a variable. Let's call it B for blue. And this B represents the price of the blue book. If the blue book is $18, then B is going to be 18. If the blue book is 25, then B is going to be 25. To make this an equation, and we're going to talk about this deeper in further lessons, we need to write an equal sign in between them. This gives us a relationship between the two prices, between the two characters. At this moment, we're saying that P, or the price of the purple book, is equal to B, the price of the blue book, which is not true. The problem is telling us there are differences between these two prices. And the first difference is the purple book is $10 more than the blue book. So to account for this difference, we're going to make it a plus 10, because now we are saying that whatever the price of the blue book is, the purple is going to be 10 more than that. If the blue book is 25, then we replace B for 25, and we will have 25 plus 10 equals 35. If the blue book is 15 or 13, we replace B for 13. 13 plus 10 equals 23. With this relationship, we're saying that the purple book is $10 more costly than the blue book. But that's not the only difference. We're also being told that the purple book is twice the blue book. So to account for that twice, we multiply the blue book times 2. And this is how we build the equation for this problem. The purple book is going to be twice the price of the blue book plus $10. And then we can replace B for whatever price we know of the blue book. For example, if the blue book is $5, 2 times 5 is 10. Then we add the other 10 from the plus 10, and we get that the purple book will be 20. And no matter the price of the blue book, we can replace it for B, and we will get a price for the purple. But let's do another example. It does take practice to convert these word problems into equations. So let's do another example. The height of the small building is 12 less than a quarter of the height of the tall building. So one more time, let's identify our characters. One of them is the small building. So let's put S for a small building. And the second character is the tall building. So let's put T for the tall building. We have the two characters, two letters, S and T. S for the small building, T for the tall building. We need to make this an equation. So we write the equal sign. At this moment, we're telling that the small building has the same height as the tall building. They are equal. That's what the equal sign means. But this is not true, because the problem is telling us there are certain differences, like, for example, less than, 12 less. If it is 12 less, it means we need to subtract 12. So we include a minus 12. Now we're saying that the small building is 12 less than the tall building. So for example, if the tall building is, let's say, 80 feet, then we replace T for 80. 80 minus 12, we get 68. The small building will be 68. But there is more information here. It says 12 less than a quarter of the height of the tall building. A quarter represents we divide by 4. So we need to divide t by 4, or the same, multiplying t times 1 over 4 is the same. And now we have an expression or an equation that will help us find the value of the small building. So for example, if the tall building is 100 feet, we replace t for 100. So 100 divided by 4, that's 25. Then we subtract 12. 25 minus 12 is 13. So the height of the small building is 13. For more math lessons like this one, visit our website, mathusermanual.com, or follow us on Instagram at mathusermanual.